Good evening. We are Group 5. Our team consists of Kevin Ward, Will Scott, Ivan Chan, and we will be presenting our planning report. Our main objectives for this project include maximizing points in order to win the competition. To do this, we need to push F out of the quadrant, place an A into the transcript, steal the T, and get sleep. Our other objectives include following all rules and meeting deadlines, and of course having fun, which will most likely happen if we win the competition. One important planning tool that our team utilizes is a planning tree diagram. The main steps outlined in our planning tree were understanding the problem, producing a preliminary design, creating a prototype, testing the machine, and then ultimately preparing for the competition. As you can see, the largest step is creating the prototype because it has the highest number of sub-steps. In order to effectively allocate our time and efforts, the team developed a prioritization matrix. On the left-hand side of the matrix are the 9 main tasks the group must accomplish in order to stick to the planning tree. By determining the relative importance of these tasks in relation to each other, the group was able to determine which tasks needed to be accomplished first, as well as which tasks needed to be given the greatest focus. Among these were constructing and testing prototypes, as well as buying materials and selecting concepts in order to do so. From the planning tree and prioritization matrix, a Gantt chart was developed in order to present a tentative schedule and outline for when the tasks need to be accomplished. In accordance to the planning tree as well as the prioritization matrix, producing a prototype and then redesign and final design take the most amount of time, as they were decided to be the most important from the other charts. The dates on the chart were determined by the deadline set in class as well as goals set by the group. Once project planning was complete, the group began design planning. Here's a function tree listing out the functions which our design must accomplish in order to score the most points. Another very important design tool is the House of Quality, which we derived from our function tree as well as guidelines set out in class. On the left-hand side, you have the customer requirements as well as the engineering requirements above. Removing the T from the tower and reliability were weighted highest in order to get us the most points and advance us further into the rounds. The arm reach was determined to be the most important engineering requirement, followed closely by arm turning speed as well as physical dimensions. Finally, a specification sheet was developed using the House of Quality as well as the rules set out by the project outline. The most important specifications being the size, being able to box 1 foot by 2 feet by 1.5 foot, as well as the energy that's allowed to go into it, which is the mouse traps, the provided pneumatics, the controller energy, as well as gravity. Finally, in the conceptualization portion of the design process, a morphological chart was made. In order to combine all ideas of expanding and contracting, gripping the T, collecting pillows, as well as removing F's and gathering A's. From this chart, our group will be able to select the best combination of designs in order to accomplish our objective of scoring the most points. In conclusion, from all our charts, diagrams, and matrices, the team is able to see what needs to be accomplished, when it needs to be accomplished, how. The only thing left to decide is who needs to accomplish it specifically. Next step in our design process would be deciding on our preliminary design in order to begin prototyping, which we've put so much emphasis on. This concludes our presentation. Thank you for your time.